This is part 2 of a collaboration between Isaac Arthur and myself regarding the concept of uplifting. The idea that a species, whether native to your own planet or one you might run across in the depths of deep space, could be biologically or technologically augmented to be nearly or as intelligent as yourself, and whether you should do that at all. Do check out part 1 on Isaac's channel, link in the description below, and in the end screen of this video, though I suspect many of you are already well acquainted with his channel, which is one of my own personal favorites on YouTube, and one I've been watching since before I started making videos. Uplifting is a tricky subject because it gets into ethics and how that relates to futurism, though in fairness, most of modern futurism presents a host of coming ethical dilemmas when you get down to it. We're getting pretty advanced. We may think we are not, but in fact we may have a solid chance of currently being the most advanced civilization present in this galaxy. After all, we do not see a Milky Way full of Dyson spheres happily emitting brightly in infrared with radio beacons screaming hello everywhere. This is a contentious subject that we often talk about, but by and large, when we look, we really just see a whole bunch of stars, the vast majority of which are behaving completely like natural, normal stars, and that may be telling. That we don't see obvious signs of intelligent civilizations in the universe, as Enrico Fermi pointed out, does not bode well for the existence of a standard view of a Kardashev Type 2 or 3 civilization being present in the Milky Way. Kardashev could have gotten it all wrong. And perhaps advanced civilizations aren't at all obvious and may not use energy as he envisioned. Maybe we wouldn't even know what we were looking at if we saw such a civilization. Or they may just not be there at all. In the context of science fiction and how our galaxy has been envisioned as far as being inhabited, specifically that relating to the Prime Directive and the supposed ethics of it, the landscape of the galaxy may not be what the writers of old once imagined. This is because the realities of intelligent life on exoplanets in the Milky Way may no longer align with what was envisioned in past decades, especially given what science has learned in the meantime. While the universe affords apparently ample room and opportunity for life to arise, and even evolve to higher forms, it may not be so nice for highly intelligent life like ourselves, and may require very strict conditions within an exactly suitable environment to get to our level. And more importantly, leave the home planet. That may not happen often. From the start, a lot of the universe is off limits as far as life is concerned, at least in terms of an intelligent civilization arising. Though existent advanced civilizations could make use of just about anything in the universe with the right technologies. For example, we've known for a while that certain types of stars would not be prime candidates for habitability. Giant stars, for instance, tend to be short-lived and subject to supernova self-destruction. You just don't have the kind of time with those stars that you need for complex life to develop even without addressing the stability or lack thereof of the star. You need only understand the fact that many of these stars have lives on order of only a few million years, whereas on Earth, life literally took billions of years to develop human intelligence. And even then, it happened for us only because of suitable oxygen levels, which at times in the past Earth has not had, even though life still abounded here.
This can go both ways. However, there are some indications that life could evolve complexity faster, at least hypothetically, than it did here on Earth. It could be the case that complex life here arose several times and failed before gaining a real foothold because it kept getting reset by natural disasters. Earth is not perfect in that regard. Under even more ideal conditions, it may happen faster, and intelligence may arise sooner. And intelligence, once it does evolve, as I mentioned in part 1, seems to blossom. This planet has all sorts of intelligence other than our own, such as the dolphins, elephants, octopi, other primates, some of the birds, and of course cats and dogs, and many other animals that score pretty highly on the intelligence scale, even though they do not equal human intelligence. Intelligence of some level happens in many different animals. That's Earth, but does it happen that way for the universe at large? If human-level intelligence is rare in the universe, which we both agree is a pretty solidly viable solution to the Fermi paradox, then our own animals may score pretty highly in their own right as far as intelligence in the galaxy is concerned. That implies that intelligence, wherever we find it, whether on this planet or others, could be seen as extremely precious and unique. Because of that, you don't want to leave it alone and to its own devices. Instead, you want to help it and keep it going either by uplifting through augmenting them biologically, or uplifting by simply grabbing them off their world and helping them along to be the best they can be. You may be asking, why not leave them alone and just watch from afar, as in the Prime Directive? Aside from intelligence being precious, there are several reasons you might not want to obey the directive. One case could be alien ignorance. Planetary atmospheres can vary wildly, and some atmospheres could be opaque. Look at Titan. Life is hypothetically possible there, but it is bathed in orange smog. Life may or may not be able to produce intelligence on a world like that, but say for a moment it did, and say it was locked in an ocean as well. In such conditions, the residents of that world may not be aware that there is an entire universe out there to strive to explore. They may see the universe in a variation of how we saw it centuries ago. Instead of celestial spheres within spheres, as the ancient Greeks envisioned things, for a species with a thick atmosphere, there may be no point in looking at the sky at all, because it really just looks like a huge orange barrier that contains your entire universe. Jokes and theories about what lies beyond our own universe aside, what do you do then if you come across that kind of civilization? What happens if you came across them just as their star was about to die, and they have no idea what was happening?
Or say they do know. Imagine the terror of being a locked-in civilization completely at the mercy of a dying star with no ability to build rockets. As Isaac mentioned, say they live on a super-Earth with a gravity well too great to allow for escape. Imagine, if you will, that you know what your star is, have ideas on how it works and can predict its actions, but in turn also know that it's at the end of its road and about to annihilate you, and you also know that you're stuck in an ocean with no way of doing anything about it. You are trapped and merely awaiting the great boiling. Why wouldn't we save such an intelligence if we stumbled upon it? Especially if intelligent life is very rare and precious in the universe. That's probably more likely than not to be the case. Isaac has just such a video on that link in the end screen of this video that delves deeply into the concept of rare intelligence as a solution to the Fermi paradox. But one reason why we can probably safely assume that intelligence is at least uncommon in the universe is the nature of stable stars that don't go supernova. The possibilities there are not as great as some have advanced in the past. So-called G-type dwarf stars, such as our own Sun, which shouldn't really be called a dwarf since it's actually rather large as far as stars in general go, also tend to actually be hard stars for life to develop around. You need a certain type within that class, i.e. the Sun, to do it. From the other side of things, the smallest, longest-lived stars, the red dwarfs, don't seem to be very suitable either. Red dwarfs are small and low energy. As a result, the habitability zone, at least as how it's seen right now, would be very close in to the star. This is a problem from the start. The closer you are to a star, the more radiation you get from that star, even if it is small and cool. Recent papers have advanced that red dwarfs are just not very good for habitable zone Earth-like planets, even though their extreme longevity would seem to favor a civilization living around one. The reality is that they may strip their habitable zone planets of atmospheres very early on and assault them with radiation from then on out. The prospects are not good for Earth analog worlds in that case. These are stars that spacefaring civilizations might consider for retirement real estate, but not as the birthplace of a civilization. However, current thinking also is that where the magic may happen most often is in systems based on orange dwarfs. These do seem to be suitable for Earth-like worlds and sit between the red dwarfs and the yellow G-type stars like the Sun, with a habitable zone further out and less subject to radiation from the star. This is where you might find water worlds like Earth, maybe even better than Earth. But Earth-like planets are not the only kinds of water worlds. In fact, Earth worlds may be the least common type of liquid water planets for life to arise, because the other type seems far more common and not dependent on being within a habitable zone at all, even very far away from the parent star. In fact, under the right conditions, they may not even need a star at all if the planet has geothermal energy driven either by radioactive decay in the planet's core or tidal flexing creating friction from a nearby gravity source. But if you look at surface liquid water in our own solar system, you find that even if you have it on a planet, it's hard to keep it. You find that Venus once likely had it, but now does not. Earth, of course, does have it now, but won't forever. And Mars definitely had it in the past and may still have it deep underground in salty aquifers, but with no oceans. But then you get to the outer solar system, where, surprisingly, you find apparent oceans of liquid water seemingly everywhere. But it's a different situation. The liquid water of the outer solar system occurs under ice shells. This list for alternative liquid water is huge for us. The outer solar system moons Europa, Ganymede, Callisto, the asteroid Ceres, Enceladus, Dione, Titan, and Triton all have potential oceans, and the list of suspected liquid water grows each year. In fact, even wildly volcanic but warm Io might have moisture lining the walls of ancient lava tubes where at least microbial life might get a chance at a foothold. Salty liquid water does not appear to be rare, even outside habitable zones. Now, not all of these places are going to allow for intelligent life to arise. It's probably not going to get much past microbial in a place like an Io lava tube, but if the right circumstances existed in an ocean, say Europa's, then who knows what might eventually develop. That too is a solution to the Fermi paradox. Intelligent life may be common, but does not have the environment and physiology to become a spacefaring civilization due to being locked under ice in an ocean. Such an intelligence, even if it developed, may live in total darkness and never develop eyes at all, or if it did develop something like bioluminescence, would it see much other than a solid wall of ice, making astronomy and advancement into space off limits far longer than it was for us with our vibrant night sky. Also, intelligent life may still be rare even with ice shell worlds, but also may become more common as the universe ages, especially if you have a few intelligent species, say one per galaxy, out-altering the equations by uplifting everything. The longer you go within reason, the greater the possibilities, though there comes a time when there just isn't much of a universe left to develop anything at all. But with Europa-like ice shell worlds, here's where the problems begin for developing civilization. Just how much water do you have on these ice worlds, or Earth-like worlds, and how does that affect how a civilization can develop? For an Earth-like planet, too much water can mean, obviously, no land. Not having the ability to walk on land does not seem to mean you're stuck as far as intelligence and evolution is concerned. There's lots of intelligence in ocean animals, but if you have no land at all, it may mean that you're literally stuck regardless of how smart you are. But what is land? At its most basic, it's something that you can walk on. On an ice moon, you can walk on ice. We also have two icy ocean moons in this solar system that have clear signs of interaction between the surface ice and the ocean below. Europa and Enceladus both have jets of material that spray into space originating in the oceans below that comes up through fissures. Can ice serve the role of land? This brings us to a concept known as Dyson's sunflowers. Freeman Dyson, which if you watch either of our channels needs no introduction, envisions a scenario where a species could develop a surface presence on one of these kinds of moons through evolving methods of harnessing sunlight on the surface and maintaining, at least initially, a connection to the ocean below through a kind of root system. All they need is one thing that our plants typically don't have, a way of gathering heat. Dyson points out that such a complex plant-like species could hypothetically exist in our own solar system, though he admits it's pretty new ground and might not be all that likely. At the same time, there are a number of species of microbes on Earth that can withstand ridiculous amounts of radiation. And there is, of course, the tardigrade, which can, for a time, survive the conditions of space itself, so Dyson's sunflowers may not be that far of a stretch after all. But can intelligence develop from that kind of life, or use the interaction between the surface ice and the ocean below to develop a civilization? I think it would be very hard. Those are some seriously harsh conditions, not the least of which is no real atmosphere, but not entirely out of the question. And to take it further, what might occur on a water planet that doesn't have any land, but does have sea ice? Can a civilization evolve and develop on an Arctic-style ice cap? Can fire be mastered there by burning dried ocean matter? Can materials from the ocean floor below then be used to build a civilization? These are open questions, but the point is that other than on the right mix of a planet, such as Earth, developing a civilization may be extremely difficult in the universe. But intelligence, even human-level intelligence, may happen more often than civilizations do. This tends to favor uplifting as an ethical activity. If you keep finding intelligence at or near your own level on water worlds and ice moons that is locked in, so to speak, you may wish to help them along, as we covered in Part 1. But there's another take. What happens when you find a perfect world, perhaps better than Earth, that has not yet developed an intelligent species on your level, but is very close to doing so? Say you find a world that is populated with the equivalent of Neanderthals, and maybe something even better, an analog of Homo sapiens is just dawning. Based on your own history, you know that in a few 100,000 years, this world could produce something that will head out into space, and eventually, given enough time, threaten your hegemony, and unpleasantness is likely to occur, especially if aggressiveness seems a likely trait. You might ask yourself if having them develop is a good idea, a warlike species arising and necessitating warfare. Should you tweak them to be nicer, genetically speaking? Is it a moral imperative that you do so for the good of the future galaxy? What happens if you find a species that has technology, such as one that possesses rockets and nuclear bombs, but has not colonized its own solar system? What might you do then? Is it possible that you might consider it more ethical to do the opposite of uplifting, let's call it downshifting, where you might alter that species to be less intelligent and less able to develop such weapons, because that might be better and more ethical than wiping them out before they become a threat? Dumbing things down may seem rather mean, but you may have no problem doing this if you're a post-biological machine civilization that sees life as just another kind of biochemical machine. You may even see it as altruistic to do this, since ignorance is bliss in a universe that's generally hostile to everything. Or worse, the universe turns out to be a computer simulation, and it's simply better for the biologicals not to know about that, as it might depress them. Speaking of nukes and not having colonized our solar system, so far we have taken the concept of uplifting from a viewpoint that we would probably be the ones wandering the galaxy doing the uplifting, since, after all, we're the smartest thing we know of. But the situation can be reversed. We might end up in the position where someone might arrive tomorrow, and instead of destroying us, might uplift or downshift us. This smacks of the Borg, of course, but there may be friendlier ways this could happen, and with the right technique, say something dealing with nanotechnology or discrete biotechnology, we might not even be aware that we were being uplifted or downshifted, any more than we were aware that natural evolution was increasing our intelligence long ago. At no point in the history of the evolution of what led to the Cro-Magnons was it likely that everyone stopped and said, "Hey, we're getting smarter." It was simply too gradual for that. Such might be how uplifting or downshifting might work, but there are other scenarios to consider. One interesting one would be a rescue mission. Say we destroy ourselves and reset our civilization with a nuclear war. It would be hard to detect, but if some species that was passing nearby saw the characteristic emissions of a nuclear war, or the effects of it, they might head our way to help us pick up the pieces, much like one lends help to others after a natural disaster.
A more pleasant variant of this scenario would be like that of the movie Contact, where it is implied that we will be slowly uplifted to join the galactic community over time through baby steps, though I think this would be a maddening state of affairs, and certainly was for Jodie Foster. And ethics comes in here too. If they can cure all disease, but withhold that knowledge until we are sufficiently developed in their opinion, we may just be a bit cranky about that. Or say we reset ourselves and never recover, but endure in a permanent dark age. Say the reset locks us here on Earth by sufficiently changing the equations such that we cannot or simply do not recover. History has examples where the rise of technology could have occurred earlier than it did, but failed to. A shining point of what-if history is the invention of the steam engine. Heron of Alexandria stumbled across it in the 4th century. Lots of people knew about his steam toy, but no one thought to put it to work. After all, when you have lots of ready slave labor during your period of empire building, developing labor-saving devices is probably not too high on your interest list. But imagine if someone had realized that it was not merely a novelty. Imagine if Greco-Roman equivalents of Thomas Newcomen and James Watt had come along and recognized Heron's engine for its potential. Paralleling human history as we know it to that scenario, they would have progressed over a few centuries to where we are today, much earlier in human history. For example, the Roman Empire would have been going to the moon in the 4th or 5th century instead of falling into decline. Say that failure happens over and over to a species, and they never reach technology other than primitive forms of it. And indeed, there are still Stone Age, uncontacted primitive peoples living on this Earth, very much as humans lived thousands of years before we could smelt metal, albeit though there are very few of these groups left.
One such case are the Sentinelese. This is a case where you have a group of humans that, even though we are an advancing civilization, we have left alone to survive in Stone Age conditions on an island in the Indian Ocean. There are good reasons for this. For one, they are extremely hostile and try to kill anyone that sets foot on their island. And two, we might end up killing them by introducing them to our diseases for which they have no immunity, making up a kind of prime directive employed by anthropologists in our own civilization. And a fair point it is. Contact like that has gone disastrously before, but there's another problem, speaking of diseases, that goes the other way. The size of this tribe is not known. Can't exactly take a census on an island where everyone tries to kill you if you land. All census takers can do is count by helicopter. It may be a few hundred, but observers from afar didn't spot that many, and it could have been as few as 40 in 2001. More recently, in 2011, after the 2004 Indian Ocean tsunami, they saw only about 15 individuals. Undoubtedly, there are probably more than that living on the island. It's a huge island, and watching from afar doesn't really show the people that may be hiding from the helicopter hovering above them that they have no understanding of. But even if it were 500 people, so few people in a place that's been isolated for a very long time are not going to have a particularly diverse gene pool, and at some point, that's going to be a problem. And if they get hit with another natural disaster, say another tsunami, should we intervene? Should we culturally uplift uncontacted peoples here on Earth? Some would say no. It might be better that they go extinct, or just let affairs take their natural course until they contact us. But what if it was us in that position? Our own sun is increasing in luminosity and will continue to do so. Eventually, only very resilient life will be able to hang on here. Earth probably won't be wiped completely devoid of life until the sun finally engulfs us when it goes red giant, but civilization, megafauna, and intelligent life face days that are numbered, though in fairness we do have hundreds of millions of years to prepare for this. But say we don't or can't prepare. Say some calamity or series of calamities lock us in on this planet, or worse, and cause us to evolve the opposite way and lose some of our intelligence. Say this is the case just about the time that the sun's luminosity is ready to overwhelm us and begin the process of slow cooking this planet. Not a nice thought at all. Wouldn't it be nice if some altruistic alien civilization came along to liberate us from the conditions of our aging solar system? Perhaps, but I suppose what would result of that would depend on the intentions of the aliens. Would they be nice to us afterwards and help us back on our feet, or would we be their intelligent chimpanzees kept at whatever intelligence level they see fit? But then again, anything is probably better than extinction, and any kind of consciousness, uplifted or not, is better than nothing. And perhaps it will be the case that uplifting of any type is just too creepy, and we, and any other civilizations that may be out there, refrain from doing it at all. We shall see. Anyway, in the end, all of this has just been food for thought, but we leave you with one final question. What happens if the first communication we get from an alien civilization is a distress call? Thanks for listening. I am John Michael Gautier.
And I'm Isaac Arthur, and we hope you enjoyed this collaboration.
And be sure to subscribe to our channels for more explorations into the worlds of science, futurism, and whatever may await us in this amazing universe in which we live.